Welcome to the digital learning platform of Center for NEMS and Nanophotonics, Department of Electrical Engineering, IIT Madras. This video platform is meant to educate, train, and develop human power under Indian Nano Electronics Users Program, sponsored by METI, Government of India. In this video, we will learn about photolithography, which is a process to transfer a geometric pattern from a photomask to a photoresist on the substrate with the help of photons or light. Let us first learn about the photoresist and photomask. The photoresist is a photosensitive chemical which after the exposure becomes softer or harder depending on the resist. After the subsequent development process, it becomes soluble or insoluble in the developer solution. In this way, we obtain desired patterns transferred onto the substrate. Here we have S1813 photoresist, which is a positive resist, which means that when we expose this positive photoresist, PPR, through a photomask, the parts that see light become softer and soluble in photoresist developer solution, that is MF319. Negative photoresist behaves in the opposite manner. Now, let us see the photomask. A photomask is an opaque glass plate with transparent features written on it. Photomasks are made by a fabrication process where a computer-aided design is transferred to a thin layer of chromium on a glass or fused silica substrate. So now we are going to transfer these patterns, shown on the mask plate, onto this silicon dioxide substrate. There are three basic process steps to transfer a pattern from a mask to a wafer, that is, spin coating of photoresist, exposure and development. Let us start with a spin coating procedure. Spin coating is the procedure for making very thin films of photoresist onto the substrate. Spin coating procedure. The wafer is initially cleaned and heated to remove any moisture from its surface. Dehydration bake at 120 to 140 degrees centigrade is generally required for the adequate adhesion of photoresist. The photoresist is then spun on the surface while the wafer is kept rotating at high speed, generally 3000 to 5000 rpm, depending on the recipe being used, and this spin speed determines the PR film thickness. Wafer with photoresist layer is then heated to drive off solvents and to solidify the film. Pre-bake or soft bake typically at 80 degrees centigrade to 100 degrees centigrade. It ensures that the substrate does not stick on the photomask plate during exposure. This is our wafer after spin coating. Ideally, we should not expose the wafer with light before the actual exposure. The substrate is now ready for the exposure. Let us go to the exposure machine. This machine is Carlson's MA6 BA6 mask aligner. Exposure process. Starting the machine. Now let us load the mask in the machine. To load the photomask, press the Change Mask button. Take out the mask holder slowly. It should not touch the edges. Gently place the mask holder upside down in its stand. Release or pull back the mechanical lock and keep the clean photomask in the slot of this holder with chromium coated side facing upward. During exposure, the side will be making contact with the sample. Press Enter to allow the vacuum to hold the mask plate. Keep back the mask plate holder in its slot and press Change Mask to lock the mask holder in its position. Now, pull out the substrate holder and load the substrate in a position where the mask will be approximately aligned with the sample. Push the holder back into the system and press Load, and then press Enter. The mask and the substrate will now come into contact. Check for the alignment. When the display shows Align the sample, carry out the alignment. Just make sure that the mask comes at the middle of the substrate. Where the alignment is done, press Exposure. Move away, as you should not look directly at the ultraviolet light or its reflection. The exposure process will be over in just some seconds, that is 18 seconds. After the exposure is over, pull out the substrate holder, unload the substrate, and put the holder back in place. Use Change Mask option for unloading or changing the mask. We will see the transferred patterns on our wafer after the development. Development of the exposed substrate. This has to be done immediately after exposure. In a clean beaker, take the required amount of developer, that is enough to submerge the substrate. Take DI water in another beaker. Dip the substrate for around 25 to 30 seconds. Now take out the substrate and immediately rinse in DI water beaker. Dry it gently using an air gun. Inspect using microscope whether the development is proper. Now the transferred pattern becomes visible on the substrate. Switch off the machine by turning off the display, that is the green knob. Switch off the UV source lamp by pressing Off button. Wait for the lamp to cool down. Switch off power knob and 2 back side switches. Close nitrogen valve.